Okay, in this video I'm going to cover the subphylum Anthozoa, which, as I mentioned earlier, used to be in the class Anthozoa, and you'll probably still see it listed as a class in many of the other resources that you have available to you. Okay, so one major feature is that within the Anthozoans, there is no medusa phase. There's only the polyp body form. And that also means that the gametes are going to then be directly produced by the polyps gastrodermis. Because there's no medusa phase to produce the gametes, the polyps have to. So they do that in the gastrodermis. Anthozoans include organisms like sea anemones, which are very large, robust polyps, as well as the corals, which have a major importance in tropical ecosystems throughout the world. One important feature of anthozoan polyps is that they're larger and much more complex than those smaller hydrozoan polyps. And they have a number of features that you won't see in a hydra or other hydrozoans. One of these features is something called the pharynx. And you can think of the pharynx as sort of a throat, if you will. So the pharynx then is an important feature that allows the organism to take in food, sort of swallow it through the mouth, and it's a muscular tubular structure that allows food to sort of be pushed down in towards the gastrovascular cavity. Another feature is that the gastrovascular cavity is divided into a series of mesenteries. And I'm going to talk about these on the next slide. So this shows a cross-section of a sea anemone. And remember that sea anemones are, they could be several inches across and several inches high. You know, a typical one may be 2 to 3 inches across, 3 to 4 inches high. So this is, again, a really big polyp. So if you take a cross-section here, and we'll take a look at that both in a sort of a photograph form and in this diagram over here, you'll see a number of the structures that I mentioned earlier. So these mesenteries are basically shelves of tissue that stick out from, they're sort of, I guess I should say walls. They're more like these vertical walls of tissue. Some of them go all the way and actually connect to the pharynx. Some of them don't, so they have names like complete and incomplete. But really what I want you to realize is that what the mesenteries do is that they increase, and you should already know the answer to this. I'll say, well, what do you think the purpose is of dividing the gastrovascular cavity into many sections like this? You know, what does this do? Remember we talked about these kinds of advances in sponges. Well, it has the effect of increasing the overall surface area for digestion, right? The surface area is increased because instead of just sort of a hollow tube here, you know, now we have the pharynx and the gastrovascular cavity divided into all these little places for digestion to take place. Okay. Another feature that you see is something called the siphonoglyph. Okay, and you can sort of think of the siphonoglyphs as like corners of the mouth. Okay, and that's not exactly correct because this is a cross section again through the pharynx area, so you can see the pharynx in cross section here, longitudinal here, and running alongside the pharynx on either side is this structure. It's kind of a curved structure. It has actually a little bit more complexity to it than that. And basically what the siphonoglyphs are these ciliated grooves. And these allow for water to be passing through and into the gastrovascular cavity. So the siphonoglyphs are helping to bring a current in, and all of that aids in digestion. I just also want to point out that this word colenteron is really just another name for the gastrovascular cavity. And in the old days, the cnidarians were used to be called the coelenterants because of this name, and they've kind of changed that for a number of reasons. As you'll see and read about in lab, you'll see there are even more features and structures to anthozoan polyps, and I'd like you to explore some of those features in the laboratory. Again, there are a huge diversity of anthozoans, from critters called soft corals, Gorgonian corals, hard corals, and this diagram just shows some of the features or some of the examples of anthozoans. So we want to talk about a couple of the subclasses. The first one is Subclass Octocorallia, and as the name implies, they have 8 tentacles. You can count the 8 tentacles here, and that the tentacles have these little side branches, so they're referred to as pinnate. So they have these 8 pinnuled tentacles or pinnate tentacles, and you can see the mouth here. Notice that this is a colonial organism, and many of the anthozoans, just like many of the hydrozoans, occur in a colony of interconnected polyps. And in this case, these guys secrete a skeleton that is composed primarily of a protein. So they produce something called gorgonin, or many of them do. It's a big subclass, but a lot of the so-called gorgonian corals produce this protein called gorgonin, which is sort of a central rod and also extends to include the skeleton that you see here. All of the stuff in red that you're looking at is part of the gorgonian coral. The gorgonin is also impregnated to a fair extent with calcium carbonate, but we don't see the heavy calcium carbonate skeletons like you'll see in the Hexacorallia. Here we see a couple of examples of octocorallians. Again, a sea fan, which is a gorgonian coral, and then there are these corals called soft corals that don't have any kind of a hard skeleton at all. You can see the interconnected polyps and that they're very fleshy-like corals. This is just to show you a couple of other examples of octocorallians. Here we have a sea rod, and you can see that the polyps in this colony are retracted, okay, meaning that they're pulled in towards the skeleton. And often this happens during the daytime, and the polyps tend to come out a lot at night. This other example of Ranilla and called the sea pansy, we may get one of these in lab. And again, you can see the individual polyps. If you take a closer look, you can actually count the 8 pinnate tentacles, which hopefully we'll do in lab. And they're connected more by this sort of fleshy part of the coral, as opposed to that collagen-type protein called gorgonin. The subclass Hexacorallia includes those corals that have their tentacles in multiples of 6. Usually there aren't just exactly 6, like you see exactly 8 in the octocorallians, but multiples of 6. And you can try to count these if you want to, but generally if you see a lot of tentacles, you've got a Hexacorallian, as long as you know it's an anthozoan. And so many of the larger reef-building corals, which can be called the scleractinian corals, although not all scleractinian corals build reefs. There are hermatypic and ahermatypic corals. Again, I'm trying to keep your terminology down a little bit, but it's the hermatypic corals that are the reef builders. And here you can see some reef building corals in this reef. So the structure of these guys is that, again, they're a colony of interconnected polyps, and they secrete a lot of calcium carbonate at their base. In the reef building lectures, I'm going to talk a lot more about this, but for now, let me just say that a coral colony, a reef building coral in particular, consists of a thin layer of living tissue that's at the top, and over time, polyps have secreted calcium carbonate cups, or calyces as they're sometimes called, and so they'll secrete another one and another one and another one, and years after years creates this layering of calcium carbonate. So when you see a solid, what looks like a rock, like this chunk of boulder coral or other kinds of coral, all you see are the coral cups or calyces or sometimes called a coral light, on the surface, right where the living polyps used to be. Okay, you see these septa in here that kind of anchored the bottom or pedestal part of the polyp into the skeleton. Okay, so these guys secrete this calcium carbonate and layer it over many years, and the living polyps, the living tissue on the top, is what you see at the surface. Also within the subclass are the sea anemones, as I've mentioned before, and I just wanted to say one other thing is that often anemones are home to a variety of commensalistic shrimp or fish. Certainly you guys are familiar with the Finding Nemo clownfish that are in some of the Polynesia and Old World tropics. And some of those are commensalistic, some of them are mutualistic. Those fish may actually bring food and feed the anemones. Most of the time they're not, though, but they gain protection from being within these protective stinging celled anemones that can protect them from being eaten by other predators.